Welcome to EMR Physics. I am Raju, NCERT 12th Physics. We are solving the numerical problems given in Chapter 8, Electromagnetic Waves. In this video, we are going to see how to solve the numerical problem 8.2. This is a given problem. Let us see what are the details given in this problem. A parallel plate capacitor is made of circular plates. Radius of the circular plate is given as 6.0 cm. Capacitance of this capacitor is 100 picofarad. The capacitor is connected to a AC supply and the voltage is 230 volt. Angular frequency of the AC supply is 300 radian per second. There are three questions to be answered. First question is, we have to find the RMS value of the conduction current. Second, is the conduction current equal to the displacement current? Third, we have to find the amplitude of the magnetic field at a point 3 cm from the axis between the plates. Let us see how to solve this problem. First, let us write what are the numerical data given in this problem. Given radius of the circular plate is given R is equal to 6.0 cm. This is the radius of the circular plate. We have to convert this centimeter to meter. This is equal to 6 into 10 to the power minus 2 meter. Capacitance of the capacitor is given C is equal to 100 picofarad. We know that pico is equal to 10 to the power minus 12. Therefore, this is equal to 100 into 10 to the power minus 12 farad. Next, voltage of the AC supply is given V is equal to 230 volt. This is the RMS value of voltage. Angular frequency of the AC supply is given omega is equal to 300 radian per second. So these are the numerical data given in this problem. What is asked? First, we have to find the RMS value of conduction current, that is IRMS. So this is the RMS value of conduction current. We can write the IRMS as VRMS divided by X suffix C. Here X suffix C is the capacitive reactance, which is also known as impedance due to the capacitor. Xc is equal to 1 by omega C. Therefore, we can write this formula as IRMS is equal to VRMS divided by 1 by omega C. Therefore, we can write this term as a reciprocal. This is equal to VRMS into omega C. Here, VRMS is the RMS value of the voltage. RMS value of voltage of the AC supply is given. Omega is the angular frequency. It is given. C is the capacitance of the capacitor. It is also given in this problem. Therefore, by substituting all these values, we can find the value of IRMS. This is equal to VRMS is 230. Omega is the angular frequency. It is given as 300. C is the capacitance of the capacitor. It is given as 100 into 10 to the power minus 12 farad. So by simplifying, we will get this is equal to 6.96 into 10 to the power minus 6. So this is the RMS value of conduction current. Unit of current is ampere. 10 to the power minus 6 can be written as micro. Therefore, this is equal to 6.96 microampere is the RMS value of the conduction current. This is the answer for the first question. What is the second question? Is the conduction current equal to the displacement current? So the answer for the second question is the conduction current is equal to the displacement current? This is the question. Answer is yes. We have proved that the displacement current is equal to the conduction current while the capacitor is charging as well as discharging. We have proved this conduction current is equal to the displacement current in the previous problem 8.1. If you want, you can refer that. The next question is we have to find the amplitude of the magnetic field at 3.0 centimeter. Now let us see how to calculate that. Third question is we have to find the amplitude of magnetic field at 3.0 centimeter from the axis. Let these are the circular plates of the parallel plate capacitor. These plates are connected to a AC supply. This is the axis of the plates. The radius of the circular plate is given as R is equal to 6 centimeter. We have to find the magnetic field at a point 3 centimeter from the axis. Let us take this distance as small r. Small r is equal to 3 centimeter. We have to find the amplitude of the magnetic field at 3 centimeter from the axis. The magnetic field at a point from the axis is given by B is equal to mu 0 I small r. Small r is the distance of the point from the axis divided by 2 pi r square. Here I is the displacement current, r is the distance of the point, and capital R is the radius of the circular plate. We have to find the amplitude of the magnetic field. So the amplitude of the magnetic field is taken as B suffix 0, B naught is equal to mu 0. When the current is maximum, the magnetic field is maximum. The maximum magnetic field is known as amplitude of magnetic field. So we have to substitute amplitude of the current here divided by 2 pi r square. Here mu 0 is the permeability of free space, which is 4 pi into 10 to the power minus 7 Tesla meter per ampere. I0 is the amplitude of current. The amplitude of current is equal to root 2 IRMS. We know the RMS value of current. RMS value of current is already determined. This is equal to 6.96 into 10 to the power minus 6 ampere. R is the distance of the point. The distance of the point R is equal to 3 centimeter. This is equal to 3 into 10 to the power minus 2 meter. Capital R is equal to 6.0 centimeter. This is equal to 6 into 10 to the power minus 2 meter. So we know all these values. Therefore we can find the value of amplitude of the magnetic field. This is equal to, let us substitute the values. Mu 0 is 4 pi into 10 to the power minus 7 into I0 is root 2 IRMS. So root 2, what is IRMS? IRMS is 6.96 into 10 to the power minus 6 into, what is R? R is the distance of the point, which is 3 into 10 to the power minus 2 whole divided by 2 pi. What is capital R? Capital R is the radius of the circular plate, that is 6 into 10 to the power minus 2 into 6 into 10 to the power minus 2. Here r square is there, therefore we have to square this. This is equal to, we can cancel 2 pi and 4 pi. If we cancel, we will get 2 remaining. 2 2s are 4. So this is equal to 2 into root 2 is 1.414 into 6.96 into 3, and the 10 to the powers we have to write 10 to the power minus 7 into 10 to the power minus 6 into 10 to the power minus 2 divided by 6 square is 36 into 10 to the power minus 2 square is 10 to the power minus 4. So if we simplify this, we will get this is equal to 1.64 into 10 to the power minus 11. So this is the amplitude of the magnetic field. Unit of magnetic field is Tesla. This is the answer for the given problem. If you find this video is useful, please subscribe the channel, share it to your friends. If you have any doubts, comment below. Thank you for watching this video.